Chemistry, we're moving on to our next lesson. It's a very important one in chemistry, and it's called Mass Stoichiometry. So we measure in grams, liters, and molarity. Now the first one you're familiar with, the second one maybe a little, the third one not at all. We need to convert to moles. So up there on the top, we measure things in grams on a scale. We've all used one of those, so you know how it works to measure things in grams. But thanks to some important principles in chemistry, we can convert that into how many molecules or atoms that we have. And that's what the chemical equation is interested in. It's interested in moles, these big baskets of 6.022 times 10 to the 23rd atoms or molecules. So down below, for example, it's saying that we need 1 mole of CH4 for every 2 moles of O2 to make this reaction work. It doesn't care what they weigh. It cares how many you have. If I want to put together groups of 1 senior and 2 juniors in a class, I need to just know that I have 1 senior and 2 juniors. I don't care what they weigh. That's not important. The reason we care here is because it's the only way we have a way to know how many juniors and seniors we have, or more specifically here, how many numbers of molecules that we have of each type. It's by weighing them. So knowing the type of molecule and how much it weighs will allow us to make that conversion. So what we have to have first of all is pure substances. And they can either be in gas, liquid, or solid form. Those are states of matter. We'll get into that more later. But for example, you have to have pure water, or pure carbon, or pure carbon dioxide. They can't be mixed with other substances. Then the other thing we need are these translators, the molar mass conversion. So let's say we take carbon. We have to know first of all that it's pure carbon. It's not mixed with something else. And then second of all, we need to know that conversion from number of grams that we weigh on the scale, and that will allow us to convert to number of moles that the chemical equation can then use to form relationships with the other substances down there, O2, CO2, and H2o. So we use that to get from grams down to moles, and when the time comes when we're ready, we're finished, we can get from moles in the chemical equation back out to grams again, which is something that we can weigh on the scale. So let's go ahead and see how this conversion takes place. So we're going to start off just with 3 examples. Here's the first one. It's the simplest. It's how many moles of CH4 are required to form 8 moles of H2o. So what you're going to use for the first few days and for a few times you do these types of problems is this graphic organizer. On your sheet, it's going to show you that you have some number of grams, and that's something that you weighed. So if it's either asking for a number of grams in some fashion, either that you put in or that you're getting out, you would put that number up in that row, the top row. Now on your sheet, it's going to show as the bottom row. It doesn't matter. This whole thing is flipped upside down. Doesn't really matter. Okay. All right. Then down in the chemical equation world, everything is in the number of moles. So we have 1 mole of CH4, 2 moles of O2, 1 mole of CO2, and 2 moles of H2O. By the way, the G's in parentheses and the L in parentheses are states of matter. Those will be significant in later as we get into more advanced applications of chemical equations, but you don't need to really use them right now. Okay, so in order to get from the grams that we measure in to the moles that the chemical equation understands, numbers of molecules, we need to have the translator, and that's the molar mass of each substance. So again, it has to be a pure substance, and we have to know the molar mass, the conversion between moles and grams of that substance. So for CH4, it's 16.05 grams per mole. For O2 oxygen, each oxygen is 16, so O2 is 32 grams per mole. Molar mass of CO2, you figured this out in an earlier lesson, is 44.01 grams equals 1 mole, and molar mass of water is 18.02 grams equals 1 mole of water. Notice that molar masses are always 1 mole equals some number of grams. So the molar mass for water, no matter what your problem is that you're doing, the problem that you're doing is it's 1 mole equals 18.02 grams. That never changes for water. Okay, so what we want to do is find out what are we looking for. So read the first 5 words. How many moles of CH4? So we're looking for moles of CH4. So you're going to put a question mark down there in the moles row, that's in chemical world, where the chemical equation is, and right above CH4. And then it says is required to form 8 moles of H2O. So again, you're going to be in the moles row, the bottom row, because it's asking for, or it's giving you moles, and the substance is H2O. So you're going to put the 8 right above H2O in the moles row. So it's going to look like this. There's the question mark, moles of CH4. And the 8 goes, here comes the arrow first, and the 8 goes over there in moles of H2O. And what that arrow is telling you is what you need to do to solve this problem is get from the number that you know, 8 moles of H2O, to what you're trying to find, moles of CH4. And because it's one arrow, that means it's a one conversion problem. All right, so we're going to need one equivalency, and we're going to convert that into 2 conversion factors, and we're going to use one of those to get us from moles of H2O to moles of CH4. So we're going to go ahead and write the equation up above. So up above we have 8 moles of H2O is what we're starting with, and what we're trying to end with here is some number of moles of CH4. Now notice one thing, that this chemical equation flows from left to right. CH4 plus O2, and then you see the arrow going to the right, is going to produce, the output of this equation is going to be CO2 and H2O. But the math equation is flowing in the other direction. Don't let that confuse you. You always write a math equation with what you know, what number you know goes over on the left, and what you're trying to find out goes over on the right, okay? So because it's one arrow, there's a single conversion. We have a relationship between moles of H2O and moles of CH4. And so we're going to need one conversion, and there's the equivalency. Now, where did that come from? It came straight out of the chemical equation. Look at what the chemical equation says down there in the bottom between CH4 and H2O. It says for every 1 mole of CH4 you put in, you're going to get out 2 moles of H2O. So the way you write the equivalency is exactly the way the chemical equation is written. You write 1, and then you add the word MOL because it's in the moles row, 1 mole CH4, so look up at the equation up above, equals 2 moles, again you add the word MOL, H2O. So it looks exactly the way the chemical equation looks, except you add the word MOL to each side. And that's your equivalency to solve this problem. Now, you might ask, what about O2 and CO2? They don't matter. This question has nothing to do with O2 and CO2, so you ignore them in this particular problem. Okay, now we're going to create the 2 conversion factors, and remember how you do this. This is very simple. You put one of those side of that equivalency over the other, and then you flip it. So 2 moles of H2O over 1 mole of CH4, or 1 mole of CH4 over 2 moles of H2O. So that should be automatic. That should be really easy to do once you have the equivalency. Now it's going to take one conversion because we have a relationship between moles of H2O and moles of CH4. So you got to ask yourself, which one of those 2 conversion factors are you going to put in the box up above to solve this problem? So think about it. What do you need to cancel out, and what do you need to appear on top in the final answer? Think about it. The answer is this one, the one on the right. So you're going to go ahead and put that up above. So watch how it cancels. Moles of H2O, where you see 8 moles of H2O, we're not doing anything with the 8 or with any of the numbers right now. We're just canceling units of measure. That's going to cancel with the moles of H2O on the bottom in the box. So those are gone. So you're not doing anything with numbers. You're simply canceling units of measure and substances here. So what are you left? What's the one thing that didn't cancel? Moles of CH4, and that's what appears in your final answer. If what you didn't cancel isn't the unit that you're looking for in the final answer, then you set something up wrong. You can't solve the problem, okay? You've got to go back and fix it. So moles of CH4, moles of CH4. Now that we know we've set the problem up correctly, then you multiply everything on top and divide by everything on bottom. So I'm going to multiply 8 times 1 divided by 2, and that will give us 4. Okay, and that's what goes right there. So that's the final answer. And I'm going to go ahead and put that down in the graphic organizer. But the graphic organizer down below, that chart, is only to help you see the flow of the problem. You don't put any final answers down there. In fact, you only write in your graphic organizer on your assignment very lightly in pencil, because every time you finish a problem like this, you're going to erase it and use it again for the next problem, okay? But for right now, I'm going to take away that question mark and put in the 4, and there we go. So think about what that chemical equation is saying. Down at the very bottom, it's saying for every 1 mole of CH4 you react, you're going to get out 2 moles of H2O. So if we put in 4 moles of CH4, we're going to get twice that many moles of H2O. We're going to get out 8. So that's what I mean, that you ought to look at a chemical reaction as telling you not specific numbers of moles, 1, 2, 1, 2, but relationships. If you put in 4 moles of CH4, you're going to get twice as many moles of H2O, so that's 4 to 8. All right, so that takes care of our first problem. That was a 1 conversion problem. So now we're going to move on and do a 2 conversion problem. Okay, so how many moles of CH4 are required to form 3.2 grams of H2O? So the first thing you want to do is in the graphic organizer, lightly in pencil, you want to place what you know, 3.2 grams of H2O, and what you're trying to find, some number moles of CH4. So let's look at the grams of H2O first. You put that up in the grams row, that's the one with the little children that says our world, and it goes above H2O. So you're going to go ahead and put that, there's the scale, that's what we weigh the grams on. You're going to put that right there. So notice it's in the grams row and up above H2O, grams of H2O. Now where's the question mark going to go? Moles of CH4. It's going to go the same place it did on the last problem. So it's going to be down in the moles row, the bottom row in the chemical world, and it's going to be above CH4. So it's going to go right there. All right, so now we know where we're starting, we know where we're ending. Question, can you go diagonally from 3.2 to the question mark? That would be a single conversion. The answer is no. So you have to go up and down and sideways only. Okay. So the question is, can you go from 3.2 to the left to the grams of CH4, that's right above CH4, and then down? The answer is no. We don't know a relationship between grams of H2O and grams of CH4. No such relationship exists that we know of. So what we have to do is go where we know a relationship between CH4 and H2O. That's in the chemical equation. That's the only place where we have a relationship, and it's in moles. So what we're going to then do is we're going to go down, use the molar mass of water to convert grams of H2O into moles of H2O, and that will put us in this box right here on the bottom right. Now you can move sideways. You can only move sideways inside the chemical equation. So now we're going to move across, and we're going to go from moles of H2O to moles of CH4, and that will be our final answer. So that's 2 conversions because you have 2 arrows. The one going down, those 2 arrows are actually 1 arrow going down from grams to moles of H2O, and then one going across from right to left in the moles row. So we're going to go ahead. You see the equation up above. We're starting off with 3.2 grams of H2O on the left, and over on the right we have some unknown number moles of CH4, what we're trying to find out. And we can see that this is a 2 conversion problem, so we're going to put in 2 boxes. Okay, so what's our first conversion factor? It's the one that gets us from 3.2 grams of H2O down to some number of moles of H2O directly below. And the equivalency is the molar mass. So I'm going to write that up there. 1 mole H2O equals 18.02 grams H2O. That comes from that blue box, the box that has a blue border around it. Okay, so that's the equivalency. It's the molar mass. That is how many grams is 1 mole of water. So now we're going to create the 2 conversion factors. That should be easy by now. You put one over the other, and then you flip it. Okay, just convince yourself that's one side over the other, and then you flip it over the other way around. So now which one goes in that box above? So you got to ask yourself, what needs to cancel out? What needs to cancel out, we have 3.2 grams of H2O. We're not dealing with the number right now, the 3.2. We're only dealing with the grams of H2O. It does not appear in our final answer. Moles of CH4 does, so we need it to go away. And since it's on the top, we need to put the conversion in that puts it on the bottom. So we're going to put this one in here, like that. So watch what happens. Grams of H2O cancels with grams of H2O. If we'd put the other one in there, we'd have moles of H2O on the bottom, and that would not have canceled with grams of H2O. So now what we have is we have 3.2 grams H2O times 1 mole of H2O over 18.02 grams of H2O. That means your unit there at this point is going to be moles of H2O. And if you look at the box down in the bottom right, that's where we are. We're in the moles row and we're above H2O. Now, if we did the calculation here, and you will not do this, I want to be clear on this, but I'm just showing you how this equation is flowing, then you would end up with this number down here, 0.18 moles. You're not going to do that, but I'm saying if you did. I'm just doing it to show it to you here in this video. Now we need to get from moles of H2O, that's where the 0.18 is, over to the left to the question mark. And what's the relationship between those two? Well, it's the same one we had in the last problem. 1 mole CH4 equals 2 moles H2O. So that's what you need. That's going to be your equivalency. So below the second box there, we're going to put that. 1 mole CH4 equals 2 moles H2O. Again, it comes straight out of the chemical equation. All you do is add the word MOL to each side to make it moles, okay? So now we're going to create the two conversion factors, 2 moles of H2O over 1 mole of CH4, or 1 mole CH4 over 2 moles of H2O. So which one of those two are you going to put in the second box? So look at what needs to cancel out and what needs to appear on the top in the final answer. You need moles of H2O to cancel out because it's in the conversion in box 1, and you need moles of CH4 to appear on the top because that's in your final answer. So we're going to pick this one. We're going to put it up here. So moles of H2O cancels with moles of H2O, and what's your left, the last man standing, is moles of CH4, and that's what you need in your final answer. That means we've set the equation up correctly. So now we're going to just do the math. Now that we know the equation's set up correctly to give us the correct units of measure, moles of CH4, we take everything on the top, so 3.2, you see the red box appeared above around 3.2, times 1, and then you divide by everything on the bottom. Divided by 18.02, divided by 2, and that will give you 0.89. Okay? And that will be your final answer. And now we can go ahead and put it down in that box where the question mark is. You don't need to do that. You're not putting final answers in these in this graphic organizer. I'm just doing it to show you that that's where would be moles of CH4. All right, so that's a two-step problem, a two conversion problem. Now we're going to do one more. We're going to do 3 conversions. All right, how many grams of H2O can be formed from 5.2 grams of CH4? So I want you to just be focusing in on the steps. What is the process to get to this answer? It's not any harder than the last 2 problems. It's just one more step. Okay, so again, we're trying to find grams of H2O, and we're going to start off with 5.2 grams of CH4. So there's the 5.2 grams of CH4. It appears in the grams row above CH4. And what we're looking for, the question mark is grams of H2O, and that appears right there in the grams row above H2O in the chemical equation. So then the question is, can you directly convert from grams of CH4 to grams of H2O? And the answer is no. We don't have any relationships between grams of CH4 and grams of H2O. I mean, what do I mean by that? Well, if you look down at the chemical equation, we have relationships between moles of CH4 and moles of H2O. We used those in the last 2 problems. And also moles of CO2 and O2, and we get to problems where those are what we're working with. But no, you can't go grams to grams in one step. So how do you have to get there? You do this. You go down through the molar mass of CH4. So from grams of CH4, you're going to convert that into moles of CH4, and you get moles of CH4. Now, you don't do this as a separate calculation. This is just going to be one long equation, although I do the calculation in this video for you. Now that we have moles of CH4, we need to move from left to right to moles of H2O. Okay, that's conversion we've been doing in the last 2 problems. Now we have moles of H2O down there on the bottom right. Now we need to come back out to our question mark using the molar mass for water. 1 mole H2O equals 18.02 grams of H2O. And that will get us to our final answer where that question mark is, okay? So we're going to go ahead and we're going to set up this equation. We start over on the left with 5.2 grams of CH4. You see it up there in the upper left-hand corner of the screen. And over on the right side, you see grams of H2O. That's what we're trying to find. And we see this is a 3 conversion problem. There's 3 arrows, one going down, one going to the right, and one coming back up, out. So that's going to be 3 conversions. That means we need 3 boxes. Okay, so think about it. Pause the video at any time and try to test yourself on this. What is the first equivalency? To get from grams of CH4 into moles of CH4 down below, you need to use the molar mass for CH4, that translator. So it's 1 mole of CH4 equals 16.05 grams of CH4. Now hopefully this next step is easy for you by now. You create 2 conversion factors. 16.05 grams of CH4 over 1 mole of CH4, or you flip it. 1 mole of CH4 over 16.05 grams of CH4. It doesn't matter which order you write those 2 in, okay? So think about it. Which one do you need to get grams of CH4, because that's what we're starting with, 5.02 grams of CH4. Which one do you need to get grams of CH4 to cancel out? And it's going to be this one, because it has grams of CH4 on the bottom. So you're going to put it there, cancel grams of CH4 with grams of CH4, and now you're left with, on the top, moles of CH4. So that means you're in the box on the bottom left. Now you don't do this calculation, as I've said over and over again, but I'm going to do it just so you see how this equation is flowing. So that would give you 0.32 moles of CH4 down there in the bottom left. Okay, now what's our next conversion? Or equivalency rather. Well, it's the same one we've been using for the last 2 problems. It's 1 mole CH4 equals 2 moles H2O. It's that direct relationship straight across. The only place you could go sideways is inside the chemical equation, because that's the only place we know a relationship between CH4 and H2O, and there it is. So now you're going to turn that into the same 2 conversion factors that you did in the previous 2 problems. That one and that one. So now which one goes in the box up above? Well, we have moles of CH4 in our first box. See the first box on top? That doesn't appear in our final answer. So it has to cancel out. It has to go away. So which one of those 2 conversion factors below the second box are you going to use? And the answer is you're going to use this one. You're going to put it there and watch. Moles of CH4 cancels with moles of CH4. It has to be the same unit and the same substance to cancel. So now we're sitting in the box where we have moles of H2O. So if we did this calculation to this point, it would give us 0.65 moles of H2O. Okay? But we're not interested in that number. We want to come out and get to our final answer. And what's our equivalency going to be for that to come from moles of H2O up to that question mark? You use the molar mass of water as your equivalency. So there it is. 1 mole H2O equals 18.02 grams of H2O. You write the 2 conversion factors that you get from that. There they are. Which one is going to go in the box? Well, it's going to be this one for 2 reasons. There it goes. The first one is moles of H2O cancels with moles of H2O. But also, since this is our final conversion factor, you need the grams of H2O to appear in the final answer, and they do. They match up. If those 2 were not the same, you would have set the problem up wrong. So now we set the problem up right. Now we're ready to do the math. So it's 5.2, look way over on the upper left, times everything on the top, times 1, times 2, times 18.02, and now you divide by everything on the bottom. In other words, you literally hit the divided by sign on your calculator every time. Divided by 16.05, divided by 1, divided by 1. And when you crunch all those numbers, you end up with 11.7 grams of water. So if you're thirsty, you can now take the water you got out of this chemical reaction and drink it. Okay, I wouldn't recommend it. It'll probably be in the form of vapor, but it doesn't matter. So way up there where you see the question mark in the graphic organizer, you won't do this, but you could. You could put the 11.7 grams up there, and that's your final answer. Okay, so that takes care of this lesson on mass stoichiometry. What is mass stoichiometry? It means you're using mass, grams, to figure out the number of moles that you're going to use in the chemical equation. There's other ways to get numbers of moles, but in this one we're using grams. And you have to have a pure substance. It could be a compound or an element, but it can't be mixed with anything else. It can be pure water, but it can't be salt water. And the second thing is you have to know what it weighs, exactly what the mass is in grams. And then you figure out the number of moles and solve the problem.